Good morning, developers. If you are new to the channel, my name is Rob, and it is Algorithm Monday, the day that we find a code challenge or an algorithm and we work through it to stay sharp as developers, make sure that our creative problem-solving skills are still at their peak. And this is today's problem. If you just want to go for it, you'll need to know a couple assumptions, but I'm going to do it in JavaScript. And I don't know if I came up with this or not. I've used it for a long time. If you know the reference and have it, I'm happy to put it in the description. But the goal is to find the number of blue moons and the number of no full moon Februaries in the third millennium, meaning from January 1st, 2000 till December 31st of 2999. And a couple quick notes. One, a blue moon, as I am defining it, is when there's a full moon twice in the same month. So like on January 1st and then January 31st, that kind of thing. There's another definition using seasonal, and I don't understand quite how that works. We're just going to use the calendar month in this. The other one is that I am going to use the East Coast time for the United States. Depending on where you're at in the world, you might be able to see the full moon sooner or later, which would change the date slightly, which will drastically change your answer potentially. So those are two assumptions that I'm gonna make. And as I said, I'm gonna do this in JavaScript. The reason for that, we did a very similar problem in project Euler number 19, which I will link in the description if you want to check it out. That uses Python. That doesn't use any date time library or whatever. And so I'm going to use the date object just to change it up, right? So JavaScript or Node.js, and then we'll use the date object. So a couple things that you'll need to know, unless you just want to go do your own research and see what you come up with, is that a lunar month is 29 days, 12 hours, 44 minutes, and 2 seconds. The celestial bodies are so perfect in their predictability, you could probably go down to milliseconds, but it's not going to change the answer, and I don't want to write it out. What does this mean? Well, this is how long it takes the moon if you start at any given phase. So we'll just say you start at a full moon to go all the way through all of its other phases back to full. This is how long it takes, 29 and roughly a half days. And that's interesting because none of our months, which are roughly circling around a lunar month, actually are 29 and a half days, right? They're 28, 29, 30, or 31. So the full moon can fall in an odd place depending on what month it happens to be. If it's February, as you may have already noticed, you can never have a blue moon, meaning again, a blue moon is 2 full moons in the same month. There simply are not enough days. Even in a leap year, if there's one on February 1st, the next full moon would have to fall on March 1st. So that's not what we're talking about here. We're talking, one, about how many blue moons there are, and two, if there happens to be one in January, meaning it lands on the 1st and the 30th or the 31st, or the 2nd and the 31st of January, and there's only 28 days in February, February won't have its full moon because, again, it doesn't have enough days to go from January 31st to February 28th, and you can end up having it on March 1st. So in those cases, they're kind of special cases where January and March are blue moon months. We have a second full moon, and February gets skipped. So that is your job with that information. One more thing you'll need to know is that I am working on, in the year 2000, the first full moon was on January 20th, and I am going to start at 11:40 p.m. Again, that's when I think when it was at its apex. It happened to be a total lunar eclipse that year, which is kind of a cool way to start the millennium. But the first full moon that I'm working off of was January 20th on 2000. If you're in a different part of the world, you can use your own numbers if you want to, but that is what I will work off of. Okay, so pause me if you want to give it a shot. But the way that we are going to do this is I am going to use a Unix timestamp. So you may be very familiar with these, you may not be familiar with them at all. For some reason, when Unix was created, Dennis Ritchie and Ken Thompson probably decided that the apex, or the epoch of Unix, was going to be January 1st of 1970 at I think midnight. And it's just an arbitrary date. Unix, I think, was released before that. But the cool thing about this is a Unix timestamp is the number of seconds, or in the case of JavaScript, the number of milliseconds since that moment, the epoch of Unix. This is fabulous because that's just an integer. It's a big integer, but computers are really good at adding integers, dividing them, multiplying them, etc. A human mind cannot probably can conceive of whatever, right? Do the math to figure out how many seconds there were then to how many there are now, right? That's really difficult, certainly to do it all, much less fast. But for a computer, it's just doing math on two integers, and so it's awesome. So what we're going to do is we are going to start with this date. So we've got a Unix timestamp. We're going to find out what the timestamp, so the timestamp of the first full moon is going to be our starting point. And then we are going to take this information, 29 days, 12 hours, 44 minutes, and 2 seconds, and find out how many seconds there are. So 3, the number of seconds in a lunar year. So LY there stands for lunar year. All we have to do is take that number and add it to this timestamp, and that tells us when the timestamp of the next full moon. We can use the date object to get the month, and we can check to see if the months match. And if they do, you've got yourself a blue moon. And we can also check to see is the previous month January, and is this month March? And if so, February got skipped, and we can keep track of that. Okay, so that's all I'm going to do for the pseudocode. I'm going to hop over to the code editor, and let's knock this out. I am over to VS Code. I am going to use Node.js. So you can use JavaScript and make script tags and just load it in the browser. It's perfectly fine. This is an algorithm, so I'm more disposed to just get the printout here to the console. I've got the problem here. So again, we're looking for how many blue moons will there be, and how many times will February have no full moon in the third millennia. And then I've got the two options here. This is the one I'm going to use, 11:40 p.m. This is another one that I found, I don't know why, but it's like an hour later, depending on where you're at in the world. When we create an ISO date here in a minute, it's going to give us Zulu time. So I don't have an answer for that reason, because there's just a little bit of give about when this all happens. I have the Blue Moon article here for Wikipedia pulled up, and you can get this information a lot of places, but the calendar dates, it starts in 2009. I have no idea why, but it's 2024 for me when I'm making this. So the next one for me, it says will be one of these two, either December of 2028 for places west of UTC 8, and it'll be the 1st of January in 29 for those east. So again, it depends on where you're at. We want to find consistency with these, and then you can adjust the date. So this is what I am shooting for, because this information is presumably accurate for at least some part of the world, and then you can adjust the time to whatever you want. And we are going to use the date constructor here. We can hand a new date, pretty much anything, and it will kick back something, but that is exactly what we're going to do. So back over to our code, let's make two variables. We'll have blue moons, which will initialize at 0, and we will have skipped Febs, which will also initialize at 0. And we're going to have our starting date. So we'll do first full moon of 2000s, like that. And this is going to be a new date, open, close, and I'm going to hand it this string. And just to make sure that this is what we think it should be, again, it's going to be an ISO format. So it is going to be a little bit different. It's January 21st in Zulu time, which is, I think, Greenwich. And we can make adjustments if we need to. Alrighty, so our goal, as I said, we are going to work with timestamps. So this kicks back a JavaScript date, which we can do lots of great things with. Let's start off with, though, getting the phase in seconds. So we want to know what full moon phase in seconds is. And to do that, I'm going to leave that variable hanging for a minute. I'll comment it out so it doesn't bother you. But we'll do days in seconds. That's going to be, well, the phase, remember, was 29 days. We need to multiply that times 24 hours times 60 minutes times, it'll be 60 seconds. And then I'm going to add 3 more zeros, because our dates are going to come in milliseconds, and it'll just be a lot easier to just let JavaScript be JavaScript. So this is the days in seconds, 29 days times 24 hours times 60 minutes times 60,000 milliseconds. If you want, you can, of course, do this, same thing, but that covers us for days. It'll be hours in seconds, and that's going to be, remember, it was 12 hours, so that'll be times 60 minutes times 60,000, and then const minutes in seconds. That was 44 minutes, and that's just times 60,000. And then lastly, seconds in seconds doesn't make a lot of sense. I'll just do seconds, and that was 2 times, and it'll be times 1,000 to make sure that we're in milliseconds. Okay, so we take all of these and we add them together. So the days in seconds plus the hours in seconds plus the minutes in seconds plus the seconds by themselves, and we should get the number of seconds in a full moon phase. So from point to point, this much time, 29 days, 12 hours, 44 minutes, and 2 seconds, it is this many milliseconds. So come over here, refresh our code, and this is the correct number. You can go and put it in a converter if you would like to, but that is the correct number. So I'm going to comment that out. So we are in good shape. We've got our first full moon in ISO format, and we know how many milliseconds there are in a full moon. And I guess I'll put that in there. I'll do in milliseconds just to make sure that it's not confusing to you or to me. We are going to make another variable. We'll call it check date, and we're going to initialize that to our first full moon. So this is going to be our starting point. We're also going to have a variable called the previous month, and we're going to initialize that to grab the first full moon, and we're going to call get month open close. So again, we're initializing a couple more variables. This is what we're going to be working on. We're just going to keep adding this number of milliseconds to this, and we're going to make sure that we know when the last full moon was. And so we're going to start off here in the 2000s. And so we're going to say while check date dot get full year open close is less than 3,000. So this is going to be our loop that's going to keep going. So keep checking check date as long as our year is less than 3,000. Okay, so make sure before you run this that you are incrementing check date appropriately, or your program is going to get stuck. Let's get the new timestamp with the lunar full moon in seconds phase. That's kind of a goofy way to say it, but we need to find out what the new timestamp is. So cons, it'll be, I'm going to call it new TS for new timestamp. Grab our check date, and because this is a date object, it's not a timestamp, because up here we set it to this, and that is still just a standard timestamp. This is, again, in ISO format. We're going to call get time, and that will return the Linux timestamp. We are then going to add to that our full moon phase in milliseconds, and that is going to give us our new timestamp. We're going to take that, we're going to overwrite check date, we're going to make a new date, and we're going to hand it this timestamp. And JavaScript is smart enough to figure out, you gave me a timestamp, I'm going to convert it into a date object. So this will be the date in ISO format or in JavaScript date object format, whatever, of the next full moon from, again, starting at this point. Every time through the loop, we are going to bump this up to include this many more milliseconds. All right? What we want to know is if, grab the check date, because we have a date object now, we're going to grab the month, open, close. If that thing equals, back up above here, our previous month, then this is a blue moon. Because we just hit the previous month is the same as the new month after we added the whole lunar phase in seconds, or lunar month. So we will take our blue moons variable and we will plus it. And just to make sure that this is working, let's console.log, we'll grab our check date, and I'm going to put 2 local string open close. This will give us a decent looking format. And before we go any further, I want to test this out. 1, be ready for an infinite loop in case you didn't get your check date updated. And then either way, we don't need this in an else statement, because whether it's the previous month or not doesn't matter. We have to update the previous month to equal this guy here. And I guess rather than put it in 2 places, let's do new month equals, and we'll put it there like that, so we don't have to run that same code twice. So there we go. One more time. While the date is less than 3,000, or while the full the full year of our current date is less than 3,000, create a new timestamp, get the time from our check date, and add that ridiculous number of milliseconds to it, which is the full lunar month. Create a date object out of that, get the month, see if that month is the same as the previous month. If it is, we have a blue moon, and print off our local date string. Either way, we want to update the previous month, and let's put that in here, update the previous month for next time. So let's hop over and let's see how this comes out. And we got way too many here. I'm going to clear this out. Let's come back over here. And so it's not so ridiculous, I'm going to cut it off at 2040 so that we can check a little bit easier. Okay, there we go. So on October 31st, well, let's start here. July 30th of 2015. Back over to Wikipedia here. There we go. July 31st. And then it looks like January 31st of 2018. There we go. March 31st of 2018. There we go. October 31st of 2020. Okay, so it looks like, let's grab this 2037 we had in March and January. Well, it doesn't go to March, but it looks like it is working. So I'm going to adjust this back to 3,000. So our blue month count should be accurate. The only other thing that we need to do to wrap this up is if the previous month was January and the new month is March, that means that we skipped February. So let's do that. Let's do if the new month equals 2, because that's March, and the previous month equals 0, then skipped Febs plus, and when we're all done, let's find out how many we skipped. Run our code. Okay, 413 blue moons between 2000 and 2999. It looks like we didn't get one in 2999, but 2998. They will have one. I won't be here for that. And 45 times in 1,000 years did February not get a shot because it got skipped. So that is our solution. Those are the correct answers. At least I'm confident they are. But please post it if you've got other ways that you solved it, or if you ran into other issues with some of the timing and stuff. But great job. Thanks for watching. I will see you next time.